On June 11, 2026, the National Oceanic and Atmospheric Administration made it official. El Niño had formed in the tropical Pacific, and forecasters said it was likely to grow stronger as the year went on. If you like calm, steady reports on the Earth and its weather, take a moment to subscribe. The warm phase of a natural ocean pattern had come back, and this time it arrived in the middle of summer, with models pointing toward one of the stronger events in the record by winter. Its first clear mark on the American summer is a quieter Atlantic hurricane season, because El Niño stirs up high winds that hold storms back. Its hold on summer weather is real, though gentler than the grip it takes in the cold months, and every El Niño leaves its own print. In this report we'll walk through how it formed, how it is measured, why it calms the Atlantic while it stirs the Pacific, what it may do to heat and rain across the country, and how strong it could still become before the year is out. The word came from the National Oceanic and Atmospheric Administration on an ordinary Thursday in June. El Niño had arrived. Forecasters there issued what they call an El Niño advisory, and the term carries a plain meaning. The warm pattern was no longer on its way. It was here, measured and confirmed, and expected to stay a while. That agency watches the ocean the way a doctor watches a pulse. It uses a few simple labels to tell the public where things stand. A watch goes out when conditions look ripe for El Niño or La Niña to form within the next 6 months. An advisory goes out when the pattern has actually shown up and looks set to continue. So the move from a watch to an advisory this June was not a small step. It was the moment a forecast turned into a fact. For most people, the news slid by. A warm patch of ocean, thousands of miles away, sitting near the equator in the middle of the Pacific. It does not sound like something that would reach a backyard in Ohio or a beach in Florida. Yet this one patch of sea has a long arm. It can nudge the track of storms, tilt a summer toward heat, and quiet a hurricane season before it starts. The name itself is old and gentle. El Niño means the little boy, or the Christ child in Spanish. Fishermen along the coast of Peru gave it that name a long time ago. They noticed that every few years around Christmas the sea near their shores turned warm and the fish grew scarce. They did not know why. They only knew the warm water came, changed their season, and left. What they watched from the shore was the near edge of something enormous. What makes this year worth a closer look is the timing. El Niño usually takes shape later in the year. This one settled in during early summer, and the forecasters said plainly that it was still gathering strength. Their models pointed toward a moderate event by the height of summer, and a strong one, perhaps a very strong one, by the turn of the year. A few of those models reached further still, toward the kind of event the record has seen only a handful of times. There is a reason the agency speaks with care here. It has learned over many years that El Niño rewards patience and punishes bold claims. Everyone behaves a little differently. Some arrive strong and fade fast. Some build slowly and hold on. So the advisory came with confidence about the present and caution about the future. The pattern is here. How far it goes is still being written. The measurement behind the call was clear enough. In a stretch of the equatorial Pacific that forecasters watch closely, the sea had warmed well past the line that marks El Niño. By the middle of June, the water there ran about 3 degrees Fahrenheit above its long-term average. That may sound small. A few degrees in a bath is nothing, but spread that warmth across a slice of ocean larger than the whole United States and hold it there for months, and it becomes a force the entire atmosphere has to answer. That is the heart of why a distant ocean matters to a landlocked town. Heat is energy. Warm water feeds the air above it, and the air carries that change outward in wide, slow ripples. Those ripples bend the winds steer the storms, and the storms decide whose summer turns wet, whose turns dry, and who stays quiet. So the announcement was soft-spoken, but it was not small. It marked the start of a season the whole country would feel in some way, even if most people never heard the name behind it. A warm ocean had tipped, and the machinery of the sky had begun to lean with it. The pattern has a habit of hiding in plain sight. Its cause sits far offshore, out of view, while its effects show up on the evening forecast as ordinary weather. Rain that came when it should have stayed dry, heat that lingered a week too long, a storm season that fizzled. To see the hand behind those small surprises, we have to start with the thing itself, and with the simple question of what a warm patch of sea can really do. At its core, El Niño is a warming of the sea surface across the central and eastern tropical Pacific. That is the whole beginning of it. A long band of ocean straddling the equator and reaching from near the coast of South America out toward the middle of the sea grows warmer than usual and holds that warmth for months. Everything else follows from that. To picture the stage, imagine the Pacific along the equator as a shallow, sun-baked bathtub thousands of miles wide. In normal years, steady winds push the warm surface water toward the western side, toward Indonesia and Australia. The warm water piles up in the west like water shoved to one end of a tub. Over on the eastern side, near South America, that pushing pulls cooler water up from below to take its place. So the western Pacific runs warm and rainy, and the eastern Pacific runs cooler and drier. That is the ordinary balance. El Niño is what happens when that balance tips. The winds that do the pushing weaken, and sometimes they turn around entirely. The warm water that was piled in the west slides back toward the east and spreads out along the equator. The cool upwelling near South America slows down or shuts off. Now a huge stretch of the tropical Pacific that is usually cooler is running warm instead. The tub has sloshed the other way. This warm phase has a mirror twin. When the same band of ocean turns colder than usual, forecasters call it La Niña, the little girl. Between the warm phase and the cold phase sits a middle state, neither strongly warm nor strongly cold, which they simply call neutral. Together, these three states make up a single slow rhythm known as the El Niño Southern Oscillation. The ocean and the air swing back and forth through that rhythm every few years, in no fixed order. The word oscillation matters, because this is not a one-time event, it is a swing. The Pacific tips warm, then relaxes, then often tips cold, then relaxes again. The full cycle usually runs somewhere between 2 and 7 years, though it keeps no strict schedule. That is why forecasters speak of El Niño returning rather than beginning. It is a familiar visitor, not a stranger. What sets El Niño apart from ordinary weather is its size and its patience. A thunderstorm lasts an afternoon. A cold front passes in a day. El Niño is measured in months and spans an ocean. It is less a piece of weather than a change in the background against which all the weather happens. It does not make a single storm. It shifts the odds for a whole season of storms, and its reach is wide because the tropical Pacific sits at the heart of the world's weather engine. That band of warm equatorial water is where a great deal of the planet's rising air begins its journey. When you move the warmest water, you move the place where the air rises. Move that, and you move the winds that flow out from it. Those winds are threads in a web that stretches across the globe, so a tug in the tropical Pacific can be felt in places that never see that ocean at all. Scientists have a name for those far-off effects. They call them teleconnections, which sounds technical but means something plain. It means a change in one place is linked to a change in another, far away, through the connective tissue of the atmosphere. A warm Pacific and a dry spell over Africa can be two ends of the same thread. It helps to hold on to one idea above the rest. El Niño does not push weather around by brute force from a distance. It works by changing where the air rises and falls over the tropics, and by letting that change spread outward along the natural pathways of the winds. It sets the table. The weather sits down to eat. That is what the forecasters were pointing to in June. A warm band of ocean had grown and settled. The great rising column of tropical air had shifted with it, and the winds far downstream had begun to feel the pull. To see how this year's warm phase took hold, it helps to go back a few months, to a time when the same ocean was doing the opposite thing. Not long ago, this same stretch of the Pacific was running cold. La Niña held the tropics through the back half of last year and into the winter. The cool phase was never especially strong, but it was there, tugging the odds its own way. Then, as the calendar turned towards spring, it began to let go. Forecasters had seen this coming. They watched the tropical Pacific with a dense net of instruments, and for months they had tracked the cold water losing its grip. By late winter, the cool anomaly was fading fast. By early spring, the ocean had crossed back into the neutral zone, that middle ground where neither phase holds sway. For a short while, the tropical Pacific sat balanced, giving few strong signals about the season ahead. Neutral is an awkward state to forecast in. With El Niño or La Niña in place, the odds lean a clear direction, and forecasters can speak with more confidence about a coming season. In neutral, those thumbs on the scale lift away. The atmosphere is freer to do its own thing, and seasonal outlooks turn cloudier. So the early spring brought a stretch where the experts spoke carefully, watching for the next tip without yet knowing which way it would fall. For a moment it looked like it might stay quiet. Some outlooks favoured neutral holding on through the first half of summer, with only a modest chance of El Niño taking over later. The models did not all agree. That kind of spread is normal in spring, a season that forecasters treat with extra caution because the signals are often weakest then. They even have a nickname for the problem. They call it the spring predictability barrier, the time of year when the ocean's next move is hardest to read. Then the balance began to shift. Through the spring, the sea surface across the central and eastern Pacific started to warm, slowly at first, then with a steadier climb. The cool water was gone, and in its place a growing patch of warmth was spreading east along the equator. The instruments told the story month by month. The numbers were small at first, barely above the neutral line, but they kept rising instead of falling back. Below the surface, a deeper signal was building. Out in the western Pacific, a great pool of warm water had gathered down where the eye cannot see it, tens and hundreds of feet below the waves. This subsurface warmth is one of the clearest early hints of an El Niño taking shape. Like fuel stored underground, it feeds the surface warming when it rises and drifts east. Forecasters watched that hidden pool swell, and it told them the warming at the surface was not a passing flicker. It had a reserve behind it. The winds joined in. The steady easterly trade winds that normally push warm water toward Asia weakened over the central Pacific, and in places they reversed, blowing the other way. Each burst of these reversed winds nudged more warm water eastward and helped the warm phase dig in. The ocean and the air were beginning to reinforce each other, which is exactly how a strong El Niño gets built. By late spring, the trend was no longer in doubt. The warm phase had clearly won out over the neutral middle. The only questions left were how fast it would firm up and how far it would go. Model after model converged on the same answer. El Niño was coming, it was coming soon, and it showed little sign of stopping at merely weak. That agreement is worth pausing on. When the ocean and the atmosphere both lean the same way, and when many different models, run by different groups on different machines, all point to the same outcome, forecasters take the signal seriously. That is what happened this spring. The disagreement of the neutral season gave way to a broad consensus. So by the start of meteorological summer, the pieces were in place. The cold phase was long gone. The neutral pause had passed. A warm patch of ocean was spreading. A hidden reserve of heat was feeding it from below, and the winds had turned to help. All that remained was for the numbers to cross the official line and stay there, which brings us to how those numbers are taken in the first place. To call an El Niño, forecasters need more than a warm feeling about the sea. They need a number, taken the same way every time so that this year can be measured against every year that came before. For decades, that number has come from one particular window on the Pacific, a rectangle of ocean straddling the equator in the central part of the basin. They call it the Niño 3.4 region. It is a plain box drawn on the map, well out in open water, far from any coast. Ships, buoys, and satellites take the temperature of the sea surface across that box, over and over, and the readings are averaged together. Then that average is compared against what is normal for the time of year. The difference between the two, the amount the water is running above or below its usual mark, is the heartbeat forecasters listen to. The rule for El Niño is simple. When the sea surface in that box runs at least about 1 degree Fahrenheit above normal and stays there long enough, the warm phase is underway. In the units scientists use, that threshold is 0.5 degree Celsius. Cross it and hold it, and the ocean has spoken. Fall the same distance below normal, and you are in La Niña instead. Stay within that narrow band around zero, and you are neutral. The word anomaly does a lot of quiet work here. It does not mean something strange or wrong. It simply means the departure from average, the gap between what is and what usually is. A warm anomaly is water warmer than its own seasonal norm. Forecasters speak in anomalies because raw temperature by itself can mislead. The Pacific is warmer in one season than another as a matter of course. What matters for El Niño is not how warm the water is, but how much warmer than it ought to be. This year, the readings from that box tell a clean and steady story of warming. Across the late winter months, the water in the region sat just below the line. As spring came on, it edged up. By the heart of spring, the 3-month average had crept above the threshold. a modest reading a hair below 0.5 degrees Celsius, which is about 0.8 of a degree Fahrenheit above normal. Small, but on the warm side of the line at last. From there, the climb quickened. Within a month, the single-month reading had pushed close to a full degree Celsius above normal, nearly 2 degrees Fahrenheit. And by the middle of June, the freshest weekly measurement had jumped further still, to about 1 7/10 degrees Celsius above average, or roughly 3 degrees Fahrenheit. Each new number came in higher than the last. That upward march, not any single figure, is what convinced forecasters the event was strengthening rather than stalling. 3 degrees Fahrenheit above normal, across a box of ocean that size, is a serious warm signal. It carries the event past the weak range and into moderate territory, with room to grow. To picture the scale, imagine the surface of a sea larger than the lower states running a few degrees hot, day after day, week after week, pouring that extra heat into the air above. That is a large amount of energy set loose into the sky, and the sky cannot help but respond. Forecasters do not lean on the ocean alone, they also watch the air. One long-running measure tracks the seesaw of air pressure between the western and eastern Pacific, a pattern known as the Southern Oscillation. When El Niño takes hold, that pressure seesaw tips in a telltale way, and this year it has tipped hard in the direction that says the atmosphere is answering the ocean. When the sea and the air agree, forecasters trust the signal more. A warm ocean with a quiet sky can fizzle. A warm ocean with a sky that has clearly shifted is the real thing, so the number crossed the line, kept climbing, and the air moved with it. That is the evidence behind the advisory, plain and checkable. Yet even a measure as trusted as this one has a weakness, one that has grown more troublesome as the whole planet has warmed. This year, for the first time, forecasters leaned on a new yardstick to see past it. There is a quiet problem hiding inside that trusted number, and it has been getting worse for years. The world's oceans are warming overall slowly and broadly as the climate warms. That background heat lifts sea temperatures nearly everywhere, including inside the Niño box. So when forecasters compare today's water against an average built partly from cooler decades, the water looks warmer than the El Niño pattern alone would make it. Some of that warmth is the pattern. Some of it is just the rising baseline of a hotter world. That mix causes a real headache. If the yardstick reads warm even when the tropical Pacific is only mildly tilted, then every recent event looks a little stronger than it truly behaves. An ocean can cross the old El Niño line on the strength of the global warm-up, without the atmosphere reacting the way a true El Niño makes it react. The number says one thing, the sky says another. Forecasters needed a way to tell the pattern apart from the background. This year they adopted one. Early in the year, the agency shifted to a new primary measure with a plain purpose. Instead of comparing the Niño box against a fixed historical average, the new measure compares it against the rest of the tropical oceans at the same moment. It asks a sharper question. Not simply, is this water warm, but is this water warmer than the tropics as a whole right now? The idea is easy to grasp with a picture. Imagine a classroom where every student's grades have drifted upward over the years because the tests have gotten easier. A score that once marked the top of the class now sits in the middle. To find the truly strong students, you stop comparing them against old report cards and start comparing them against their classmates today. The new measure does that for the ocean. It strips away the rising tide that lifts all the water and asks how far above its neighbours the Niño region really stands. This relative measure carries a technical name, but the reason for it is simple. It removes the steady global warming from the picture so that what remains is closer to the true strength of the pattern itself. Under the old yardstick, this year's ocean looks very warm indeed, warm enough that some readings rival the strongest events ever recorded. Under the new one, the same ocean looks warm but more modest, closer to a solid moderate event than a historic one. That gap between the two measures is not a mistake, it is the whole point. It tells forecasters how much of this year's warmth is the El Niño pattern and how much is the warmer world it is riding on, and it explains why you can read two honest headlines about the same ocean, one calling this a possible record setter and the other calling it a moderate event. They are both true, they are just using different rulers. For the forecasters, this changes how they talk about strength. Using the older, absolute measure, the sheer heat in the water this year is striking, among the highest they have logged. Using the newer, relative measure, the event lands in more ordinary company, strong but far from unprecedented. The agency now leans on the relative measure to judge how the pattern will actually behave, because behavior is what matters to the person waiting to know if their summer will change. None of this softens the fact that El Niño is here. Both rulers agree on that. The sea in the Niño box is clearly warm, the atmosphere has clearly responded, and the advisory stands on solid ground. What the new measure changes is the sense of scale. It guards against the easy mistake of calling every warm year a monster, simply because the whole ocean is warmer than it used to be. It keeps the story honest. So there are two numbers to hold in mind as this season unfolds. One says the ocean is running near record heat. The other says the pattern, once the global warming is set aside, is strong but familiar. Both belong in the picture. With the measurements laid out, the natural next question is what actually drives the whole thing, the engine that tips the Pacific warm in the first place. Underneath every El Niño sits a simple engine, and it runs on wind. Along the equator, in ordinary times, the trade winds blow steadily from east to west. They are the great conveyor belts of the tropics, pushing the warm surface water of the Pacific away from the Americas and toward Asia. Day after day, year after year, those winds shove the sun-warmed top layer of the sea toward the western side of the basin. That constant push builds a lopsided ocean. On the western side, near Indonesia, warm water piles up until the sea surface there actually stands a little higher, and the warm layer runs deep. On the eastern side, near South America, the surface water keeps getting dragged away, so cooler water rises from below to replace it. This rising of deep water is called upwelling, and it keeps the eastern Pacific cool, rich, and full of fish. The whole arrangement holds together because the winds keep pushing. El Niño begins when that push falters. For reasons that start small, the trade winds weaken. Sometimes a burst of wind blowing the wrong way, from west to east, breaks out over the western Pacific and gives the system a shove in the opposite direction. When the easterly push eases, the warm water that was piled in the west is no longer held there. It begins to slide back east, spreading along the equator toward the Americas like water released to level out in a tilted tray. As the warm water spreads east, it does two things at once. It blankets the central and eastern Pacific in warmth, and it caps the upwelling that used to keep those waters cool. The cold water below can no longer rise through the warm lid on top. So the eastern Pacific, normally the cool end of the tub, turns unusually warm. The lopsided ocean has flattened out and the warmth has spread across the whole basin. Here is where the engine locks into gear. The warming ocean feeds back on the winds that started it. Where the sea grows warm, the air above it heats and rising air pulls surface winds toward it. That inflow further weakens the normal east to west trades, which lets even more warm water slide east, which warms the ocean further still. Each step feeds the next. Scientists call this a feedback loop, and it is the reason a small early nudge can grow into a basin-wide event over a matter of months. That loop is exactly what forecasters watched build this spring. The subsurface pool of warm water drifting east, the trade winds slackening and reversing in bursts, the surface warming climbing week by week. These were not separate events. They were the gears of one engine catching, turning and spinning up together. Once the loop takes hold, it tends to carry the pattern forward on its own momentum, which is part of why the warm phase, once declared, usually lasts the better part of a year. The same engine explains why El Niño runs in the opposite direction from its cold twin. In La Niña, the trade winds blow harder than usual, the eastern upwelling strengthens, and the cool end of the Pacific grows even cooler. It is the same machinery running fast instead of slow. The whole oscillation is really one system, tipping warm when the winds ease and cold when they surge, swinging between the two through the years. What makes this engine matter so far from the water is where it sits. The warmest part of a tropical ocean is where the air rises hardest, and rising air is the starting point for so much of the world's weather. By dragging the warmest water eastward, El Niño drags the rising air with it into the middle of the Pacific. That is a large shift in the position of a very large chimney of rising air, and everything downwind of that chimney feels the move. So the cause of it all is not exotic. It is warm water, weak winds, and a feedback loop that ties them together. A push that falters, an ocean that slides, and an engine that spins the change into something an ocean wide. The next thing to understand is what the atmosphere does once that warmth is set loose, because that is where a warm sea becomes a changed sky. When the warmest water of the tropical Pacific slides east, the atmosphere has to move with it, and the way it moves is the real bridge between a distant ocean and an ordinary forecast. It works through rising and sinking air. Over the warmest water, the air heats, grows light and climbs. Higher up, it flows away to the sides, cools and sinks back down somewhere else. That great overturning loop of rising and sinking air running along the equator is one of the main gears of tropical weather. In normal years, the rising branch of that loop sits over the warm western Pacific near Indonesia, which is why that region is so wet. The sinking branch sits over the cooler eastern Pacific, which is why that side stays drier. El Niño picks up this whole loop and drags it eastward. Now the rising rainy branch shifts out over the central Pacific, over open water that is usually calmer. The sinking, drier branch shifts east too, settling over places that used to sit under the rising side. That shift rearranges the rain. Regions that counted on the rising branch, like Indonesia and nearby parts of the western Pacific, tend to dry out during El Niño, because their engine of rising rainy air has slid away to the east. Meanwhile, the central Pacific, normally quiet, sees storms bloom over water that has turned warm. The map of where it rains and where it does not gets redrawn, all because the warmest water moved and took the rising air with it. This is the same seesaw of pressure that forecasters track with the Southern Oscillation. When the rising air shifts east, the air pressure at the surface falls in the east and rises in the west, and that pattern is the fingerprint of El Niño in the atmosphere. The ocean and the air are not two separate stories. They are one coupled system, each pulling on the other, which is why forecasters insist on seeing both before they trust an event. From that shifted engine, the effects spread outward along the winds. High in the atmosphere, the burst of rising air over the central Pacific sends out waves, much like a stone dropped in a pond sends out ripples. These waves travel along the jet streams, the fast rivers of air that snake around the globe at high altitude. As the waves move downstream, they nudge those rivers of air into new positions, and where the jet streams go, the weather follows. This is the machinery behind those far-off links, the teleconnections mentioned earlier. A warm patch of tropical ocean bumps the rising air eastward. The rising air launches waves aloft. The waves bend the jet streams, and the bent jet streams steer storms and dry spells into new places thousands of miles away. No single storm is carried across the world by El Niño. Instead, the whole steering system is nudged, and season after season the weather tends to fall a certain way because of it. The jet stream is the key middleman for the United States. It is the boundary between colder air to the north and warmer air to the south, and it is the highway that storms ride across the country. When El Niño shifts and strengthens parts of that highway, it changes where storms tend to travel and where they tend to stall. That is how a warm ocean near the equator ends up tilting the odds for rain in California or calm in the Gulf. It helps to hold the scale of this lightly. El Niño does not command the weather like a hand on a wheel. It leans on the system, shifting probabilities, favouring some outcomes and discouraging others. A season under its influence is a loaded set of dice, not a fixed result. Any single day can still surprise. What changes is the tendency over weeks and months, the slow lean that shows up when you add up the whole season. So the chain runs from water to air to wind to weather. The sea warms, the rising air shifts east, waves ripple out aloft, the jet streams bend, and storms and dry spells settle into new homes. That chain is why this report can speak at all about what a Pacific warm phase might do to an American summer. But summer is a special case, and the season the pattern has arrived in matters as much as the pattern itself. Here is a truth that keeps this whole story honest. El Niño's grip on American weather is real, but it is at its lightest in summer. The pattern speaks loudest in winter. That is when its fingerprints show up most clearly on maps of the United States, and it is when forecasters lean on it most heavily to call a season. In the warm months, its voice drops to something closer to a whisper. The reason lies in the jet stream and the strength of the pattern's own signal. In winter, the temperature difference between the cold poles and the warm tropics is at its sharpest, and that sharp contrast makes the jet stream strong, fast, and easy to shove around. A vigorous jet stream is a long lever. When El Niño's ripples push on it, the whole storm track can slide, and that slide reaches deep into the country. So a winter under El Niño tends to follow a recognizable script across North America. Summer softens all of that. The poles warm, the contrast between north and south eases, and the jet stream weakens and pulls back toward the north. A weaker jet is a shorter lever, harder for El Niño to move, and its position matters less to daily weather in the lower states. At the same time, El Niño itself is often still building through the summer of its onset year, not yet at full strength. A growing pattern pushing on a slack jet stream simply cannot rearrange a summer the way a peak pattern rearranges a winter. So the honest framing for this season is one of tendencies, not certainties. Summer under El Niño does not come with a bold, reliable map of who gets what. It comes with a handful of gentle leans, some more dependable than others, laid over the ordinary chaos of a warm season sky. Anyone promising a summer transformed, town by town, is promising more than the science can give. The pattern tilts the odds. It does not hand down a script. That does not make the summer signal empty. A few of its leanings are trustworthy, and one in particular stands out above the rest. But the honest place to start is by lowering the volume of the claim. This is not a pattern that will seize every afternoon thunderstorm and every heat wave from coast to coast and bend them to its will. It is a background condition, a thumb resting lightly on the scale, felt more in the season's totals than in any single day. It helps to think about which effects survive the summer weakening and which fade. The effects that depend on a strong, well-placed jet stream over the country tend to fade, because the summer jet is neither strong nor well-placed for that job. The effects that depend on the tropics themselves, on the warm ocean and the storms it feeds, hold up better, because the tropics do not go quiet in summer. If anything, they wake up. That distinction points straight to where El Niño's summer voice is clearest. It is not over the wheat fields of the Great Plains or the forests of the northeast, where the signal grows faint. It is out over the warm tropical oceans, where the pattern shapes the season of storms. There, far from the weakened jet stream, El Niño keeps its full authority even in summer, and it uses that authority to change the odds for hurricanes. So the loudest thing El Niño will say to America this summer, it will say through the tropics and the storms born there. The land may feel only a gentle lean toward heat here, or a touch more rain there. The ocean will feel something firmer. That is why the clearest chapter of this summer's story is written not over the continent, but over the water where hurricanes are made, starting with the Atlantic. The single clearest thing El Niño does to the American summer happens over the Atlantic, and it happens by making the sky above that ocean hostile to hurricanes. The tool it uses is wind shear. That term sounds technical, but the idea is plain. Wind shear is a change in wind speed or direction with height. The winds up high blowing differently from the winds down low. A little is normal, a lot is poison to a hurricane. A hurricane is a tall, stacked engine. It needs its thunderstorms lined up in a neat column, from the warm sea surface all the way up to the high cold air, so that the whole tower can spin together and strengthen. Wind shear wrecks that column. When the winds up high race off in one direction while the winds below go another, the growing storm gets tilted and torn apart before it can organize. The tower leans, the heat and moisture scatter, and the engine stalls. El Niño floods the tropical Atlantic with exactly this kind of shear. Remember the waves that ripple out aloft from the warm central Pacific? Some of those waves travel all the way to the Atlantic and strengthen the high-altitude winds over the main region where hurricanes form and grow. Down at the surface, conditions may look fine for a storm, but up above, the winds have turned fast and unfriendly. Storms that try to build there find themselves sheared apart, again and again, across the season. This is why an El Niño summer so often brings a quieter Atlantic hurricane season. It is not that the ocean grows cold or the moisture vanishes. The warm water and damp air are usually still there, ready to feed storms. What changes is the wind aloft. El Niño raises an invisible ceiling of hostile wind over the nursery where Atlantic hurricanes are born, and fewer of them make it to adulthood. The season does not empty out, but the odds shift firmly toward fewer and weaker storms. Forecasters trust this link more than almost any other El Niño effect on American weather in summer, and for good reason. It rests on the tropics, not on the weakened summer jet stream, so it survives the season that mutes so many other signals, and it shows up plainly in the record. Look back at past summers when El Niño was in place, and Atlantic hurricane seasons tended to run below normal over and over. The pattern is dependable enough that it anchors the official outlook for the season ahead. This year the setup is textbook. El Niño is present and strengthening, and the models expect it to keep firming up right through the peak of hurricane season, which runs from late summer into the fall. That timing matters. The strongest suppression tends to come when the pattern is at its most vigorous, and this one is forecast to be at or near its most vigorous, just as the Atlantic would otherwise be most dangerous. The season's busiest weeks are set to unfold under El Niño's most hostile winds. There is a wrinkle worth naming honestly, because forecasters have named it too. The Atlantic itself is running slightly warmer than normal this year, and warm water is fuel for storms. So the season has two forces pulling against each other. El Niño's shear pushes toward fewer storms, while the warm Atlantic pushes toward more. When forecasters weighed the two, they judged El Niño the stronger hand. But the tug of war is real, and it is one reason the outlook comes with a measure of caution rather than certainty. None of this means the coast can look away. A quiet season is a matter of counting storms over months, and it says nothing about whether one particular storm will find one particular shoreline. That is a point worth returning to, and it deserves its own careful telling. First, though, it is worth putting numbers to the quiet, because forecasters have already laid out just how below normal they expect this Atlantic season to be. When forecasters put numbers to this year's Atlantic season, the message was consistent from every quarter. The government's outlook, released in late spring, called for a below normal season. It set the odds at a little better than 1 in 2 for below normal activity, roughly 1 in 3 for a near normal season, and only about 1 in 10 for an above normal one. The scale was tilted clearly and deliberately toward a calmer year. Those odds came with a count. The outlook expected somewhere between 8 and 14 named storms, of which 3 to 6 might become hurricanes, and 1 to 3 might grow into major hurricanes, the strongest tier. To read those numbers well, you need the yardstick beside them. In an average year, the Atlantic produces about 14 named storms, 7 hurricanes, and 3 major hurricanes. So this year's ranges sit at or below the low end of normal across the board. A named storm, by the way, is any tropical storm strong enough to earn a name from the official list, with winds of at least about 40 miles an hour. A hurricane is a step up, with winds of at least 74 miles an hour. A major hurricane is the top bracket, with winds above 110. The outlook expects fewer of all three this year, and the drop grows steeper as you climb toward the stronger storms, which is just what an El Niño season tends to do. A respected university team that has forecast these seasons for decades came to the same place, and then leaned even further toward calm. Their early summer update trimmed their own numbers, calling for around 11 named storms, of which perhaps 5 might reach hurricane strength, and 2 might become major hurricanes. By their reckoning, the season could run at roughly 60% of an average year's activity. When 2 independent teams, using different methods, both land on a quiet season, the signal is worth trusting. That same team did something forecasters often do to build confidence. They looked for past seasons that resembled this one, years when El Niño was developing in a similar way, and they used them as analogues. The years they chose, spread across the decades, shared a common trait. Every one of them delivered a below-average Atlantic hurricane season. That history is part of why they felt sure enough to call for a quiet year, and it lines up neatly with everything the physics predicts. It is worth being clear about what these numbers are and are not. A seasonal outlook is a statement about the whole basin over the whole season, an estimate of overall activity. It is not a forecast of where storms will go or when they will strike land. It cannot tell any single town whether a storm is coming its way, because that depends on the day-to-day weather patterns that steer each storm, and those cannot be known months ahead. The outlook counts the storms, it does not aim them. That distinction is the reason forecasters pair every quiet outlook with the same steady reminder. A below-normal season is not a safe season. The number of storms in a year has little to do with whether the one storm that matters most finds your coastline. Quiet years have produced deadly landfalls before, and they will again. The outlook lowers the odds of a busy basin. It does nothing to lower the stakes for the place a single storm happens to hit. So the picture for the Atlantic is settled and consistent. Fewer storms than usual are expected, the strongest storms are the least likely of all, and independent teams agree on the calm. El Niño's hostile winds are the main reason, with a warm Atlantic offering only partial resistance. Yet the same pattern that calms one ocean stirs up another. While the Atlantic quiets down, the Pacific side of the country is set to grow busier, for reasons that are the mirror image of everything just described. While El Niño calms the Atlantic, it does the opposite to the Pacific, and the reason is the same physics turned inside out. Over in the eastern and central Pacific, where hurricanes also form and sometimes threaten, Mexico, Hawaii, and the waters off the American West, El Niño tends to make the season busier. The same pattern that raises a ceiling of hostile wind over the Atlantic lowers the barriers over the Pacific instead. Two things work in the Pacific's favour during El Niño. First, the warm water that defines the pattern sits right in that ocean, spreading eastward along the equator. Warm water is fuel, and El Niño lays out more of it than usual across the zones where Pacific hurricanes travel. Second, the high-altitude winds that turn hostile over the Atlantic turn friendlier over the eastern Pacific. The wind shear that tears Atlantic storms apart eases here, letting Pacific storms stack up tall and strong. So the storm nursery shifts. The Atlantic side, its warm water fuel intact but its skies torn by shear, produces fewer storms. The Pacific side, gifted both extra warmth and calmer winds aloft, produces more. It is a seesaw across the continent. The same tropical shift that quiets one coast enlivens the other, which is why forecasters this year expect a below-normal Atlantic, and, at the same time, active seasons in both the eastern and central Pacific. For most of the mainland, a busier eastern Pacific goes almost unnoticed, because those storms usually track away from land, out over open water, or curve into Mexico rather than the United States. But the effects are not always distant. The remains of eastern Pacific storms sometimes sweep moisture northward into the American Southwest, feeding late summer rains and at times flash flooding across the desert states. A storm that never touches the United States as a hurricane can still deliver its leftover water to Arizona or New Mexico as a drenching. Hawaii sits in a more exposed spot, and for the islands an El Niño year deserves closer attention. The Central Pacific, the basin that most directly concerns Hawaii, tends to see more activity when El Niño warms the water and calms the winds nearby. Storms that might have fizzled in a normal year can survive longer and track closer to the islands. It does not guarantee a strike, and most seasons pass without one, but the raised odds are real, and the islands watch El Niño summers with extra care. There is a broader lesson tucked inside this Pacific story. El Niño does not simply turn the world's storms up or down, it moves them. It takes activity from one ocean and hands it to another, shifting the danger rather than erasing it. A quieter Atlantic is not a quieter planet. The energy that would have gone into Atlantic storms does not vanish. It surfaces elsewhere, in a Pacific season that runs hotter than usual. The books balance, just in different columns. That is why a full account of an El Niño summer has to look at both oceans at once. Reading only the Atlantic outlook, a person might conclude the tropics have gone quiet for the year. The wider view corrects that. The tropics are not quiet, they are rearranged. One basin exhales while the other draws breath, and the same warm patch of equatorial water is conducting both. For the American public, the practical takeaway is a divided one. Along the Atlantic and Gulf coasts, the pattern tilts toward relief, a season likely to bring fewer storms than most. Along the Pacific side, and especially for Hawaii and the desert southwest that can catch a storm's leftover moisture, the tilt runs the other way, toward a season worth watching more closely than usual. The same summer carries two different forecasts depending on which shore you stand on. Still, whichever coast you call home, the deepest lesson of a hurricane season holds firm. The count of storms is not the measure of the danger. A busy basin can spare you entirely, and a quiet one can find you all the same. That truth is important enough and misunderstood often enough that it is worth slowing down on before this half of the report closes, because it is where a calm forecast and real safety meet. The most dangerous idea about a quiet hurricane season is that it means a safe one. It does not, and the difference has cost lives. A seasonal outlook counts storms across an entire ocean over many months. Safety is about one storm, one coastline, one day. Those are different questions, and a reassuring answer to the first tells you almost nothing about the second. Think about what a below-normal season really promises. It says the Atlantic will probably brew fewer storms than usual this year. It does not say those storms will avoid the coast. It cannot, because where a storm goes is decided by the day-to-day weather steering it. Patterns that take shape only days ahead, long after the season's total was forecast. A single hurricane, riding the right currents to the wrong shore, can bring a disaster to a town no matter how calm the basin was as a whole. History makes the point plainly. There have been quiet seasons, El Niño seasons among them, that still delivered destructive landfalls. A couple of summers back, in a year shaped by the tropics much like this one, a tropical storm named Idalia swept into parts of the southeast, dropping close to a foot of rain in places, driving strong wind gusts and spinning up tornadoes as it came ashore. The season around it was not a wild one. That did not matter to the neighbourhoods under the water. It only takes one. So the calm outlook and the call to prepare are not in conflict. They fit together. The outlook lowers the odds that the basin as a whole will be busy. Preparation guards against the one storm that the odds can never rule out. A wise coast holds both ideas at once, taking comfort in the lighter season while readying itself exactly as it would in any other year. The forecast is a reason to breathe easier, not a reason to look away. What that readiness looks like is standard and worth repeating in plain terms. Know whether you live in a zone that floods or that officials would ask to evacuate, and learn the route out before you ever need it. Keep a simple kit on hand, with water, food that does not spoil, medicines, flashlights and batteries, enough to carry a household through several days without power. Have a way to receive official warnings even if the lights go out, whether a battery radio or alerts on a phone. These are ordinary steps, and they matter most in the years no one expects to need them. The single most important habit is to listen when the local warnings come. A seasonal outlook is a wide, months-long view. The forecasts that save lives are the short-range ones, issued in the days before a specific storm when its track and strength come into focus. When those warnings arrive, and especially when officials call for an evacuation, the calm outlook from the start of summer has nothing more to say. The only voice that matters then is the one describing the storm at your door. There is a quiet mercy in an El Niño summer worth naming without overstating it. The odds do favour a lighter Atlantic season, and for coastlines worn down by recent hard years, that tilt toward fewer storms is a real and welcome thing. Fewer storms across a season does, on balance, mean fewer chances for disaster. That is worth something. It simply is not a shield, and no honest forecast would offer it as one. So the first half of this year's story sets a clear scene. A warm patch of the Pacific tipped into El Niño in early summer, and kept strengthening. Forecasters measured it two ways, saw an ocean near record heat by one ruler, and a solid moderate event by another, and trusted both. The pattern's engine of wind and warm water spun up. The atmosphere answered, and the clearest mark on the American summer landed over the tropics, quieting the Atlantic while stirring the Pacific. That is the ocean's half of the tale, the part El Niño tells most confidently in summer. The land has its own, quieter half. The heat, the rain, the drought, and the long road toward the pattern's winter peak all wait in the second stretch of this report, where the story moves from the water back onto the continent. Turn from the oceans back to the land, and the clearest thing El Niño leans on is heat. Across much of the country, this warm phase tilts the summer a little warmer than it would otherwise run. The lean is gentlest over the southern states and firmest over the north, but the broad drift is toward warmth, and it sits on top of a world that is already warmer than it used to be. The reason starts far from any thermometer on land. A warm patch of tropical ocean the size of this one pours a vast amount of heat into the air above it, and the atmosphere spreads that warmth around the globe over the following months. El Niño years tend to run hot worldwide for exactly this reason. The ocean banks heat during the cool phase and releases it during the warm one, and the whole planet feels the release. That global warming pulse is the most confident prediction attached to this entire event. Forecasters may hedge on rain and storms, but on temperature they speak plainly. This El Niño is very likely to push global temperatures up, and the year it peaks in, along with the year after, stands a strong chance of ranking among the warmest ever measured. The last few years were already near the top of the record. A strengthening El Niño makes new heat records a real possibility rather than a distant one. There is a delay built into this, and it is worth understanding. El Niño's biggest push on global temperature usually comes not at the moment it arrives, but in the months after it peaks. The ocean takes time to hand its heat to the air, and the air takes time to warm the whole planet. So the pattern building now, cresting toward winter, is likely to leave its strongest mark on global temperature into the following year. The heat you feel this summer is the early edge of a longer warming that outlasts the event itself. For the United States in summer, though, the temperature signal is softer and patchier than that global story. El Niño does not reliably bake every region. Its summer heat lean shows up most clearly across the northern tier of the country and up into parts of Alaska, where warmer than average conditions become more likely. The Pacific Northwest, the Northern Plains, the Upper Midwest, and the Northeast all sit more often on the warm side of normal during an El Niño summer. The official outlooks reflect this without overselling it. Going into this season, forecasters flagged an increased chance of above normal temperatures across broad parts of the country. That is a tilt in the odds, not a promise of record heat everywhere. Plenty of days will run near normal, and some will run cool. What the pattern does is shave a little off the chance of a cool summer and add a little to the chance of a hot one, region by region, more strongly in the north. It helps to hold the size of this effect honestly. The summer heat lean from El Niño is modest compared with the swing you get from an ordinary heat wave or a stubborn ridge of high pressure parked over a region for a week. Those short-term patterns still do most of the work of any given hot spell. El Niño works underneath them, nudging the season's average, making the hot stretches a touch more likely and the cool ones a touch less. It is a thumb on the scale, felt in the totals more than in any single scorching afternoon. One practical point deserves a place here. A warmer-leaning summer, layered on a warming climate, means heat itself is worth taking seriously this year, more so than storms for most inland communities. Heat is the quiet hazard. It kills more people in an average American year than hurricanes or floods, and it does so without the drama that draws attention. A summer tilted warm is a summer to respect the heat in, with the plain habits that blunt it, staying hydrated, finding shade or cool air in the worst hours, and checking on the old and the isolated. So the land's half of the story opens with warmth, broad and gentle over the country, sharper and more certain across the globe. The north leans hottest, the planet leans hotter still, and the biggest temperature push waits for the months after the peak. Yet the country does not warm evenly. The southern states follow a different script, one where the heat eases and the rain can pick up, and that split across the map is the next piece to lay down. The country does not lean warm all over. Across the southern tier, from Texas eastward through the Gulf states and into the southeast, an El Niño summer often runs a little differently, with the heat lean easing and in places a better chance of rain. The map splits roughly into a warmer-leaning north and a cooler, damper-leaning south, an understanding that split matters for anyone reading their own forecast this year. The cause traces back to the same rearranged tropics from the first half of this report. El Niño shifts where storms and rising rainy air set up, and it changes the flow of moisture across the southern edge of the country. Along the southern tier, that can mean more clouds and more rain than a typical summer brings, and more clouds and rain tend to hold the temperature down. Where the sun is often screened and the ground is often damp, the fierce heat of a clear, dry summer has a harder time building. So the southern states sit under a gentler temperature tilt than the north, near normal in many places, and at times a touch below. From Texas across to the southeast, forecasters more often expect summers that do not run as hot as an average year, precisely because the pattern favours more moisture there. It is not a promise of a cool summer in the deep south, which would be a strange thing to promise about that region in any year. It is a lean away from the extreme heat that a bone-dry summer would deliver. The rain side of this split is real but uneven, and it lands hardest toward the southeast corner. Florida and the deep south tend to see the clearest tilt toward a wetter summer during El Niño, with more of the frequent heavy downpours that already define their warm season. Those states, already among the rainiest in summer, can turn rainier still, and that carries its own small hazards, more flooding of low ground, more washed out afternoons, more days when the storms roll through on schedule and then some. Move west and north from that corner, and the wet signal fades and can even flip. Parts of the mid-Atlantic and stretches from the mid-south into the interior can lean drier than normal in an El Niño summer, the opposite of the soggy southeast. This is a good reminder that the pattern's effects are not one thing spread evenly, but a patchwork, wet in one corner, dry in another, with the lines between them blurred and shifting. The map has texture, not a single colour. That patchwork is why a person is far better served by their local outlook than by any national rule of thumb. Two towns a few hundred miles apart can sit on opposite sides of one of these leans, one tilting wet, the other dry, both under the same El Niño. The broad strokes warmer north, milder and often wetter south, damper still in the southeast, hold up across the season and across the country. The details belong to each place, and they belong to the forecasters watching that place week by week. There is a deeper caution folded into this southern split, and it is worth naming before moving on. These tendencies come from averaging many past El Niño summers together, and an average can hide a lot of variety. Some El Niño summers in the south have been wet, and some have been dry, and the average simply leans one way. So the milder, damper southern lean is a genuine tilt in the odds, not a guarantee any single summer will honour. The pattern loads the dice toward that outcome. It does not roll them for you. Hold the whole map in mind then. The north leans warm, the south leans milder and often wetter, the southeast leans wettest of all, and pockets of the mid-Atlantic and interior can buck the trend and lean dry. It is a portrait of tendencies, drawn in soft edges, useful for understanding the season's shape but never for pinning down a single day. And once you accept how soft those edges are, an honest question follows close behind. In how much of the country does an El Niño summer actually make a difference you could notice at all? Here is where honesty earns its keep. For a great many places in the United States, an El Niño summer does not look meaningfully different from any other summer. The signal that shows up so boldly in winter maps thins out to almost nothing across large stretches of the country in the warm months. In much of the interior, the pattern's fingerprint on summer weather is faint enough that you would never pick it out from the ordinary swings of the season. Forecasters have a specific way of admitting this, and it is worth knowing when you see it. When they look at a region and find no clear lean toward wetter or drier, hotter or cooler, they label the outlook equal chances. It means exactly what it says. The odds of a wetter than normal season, a drier than normal one, and one right around normal are all about the same, because no pattern, El Niño included, is pushing hard enough to tip them. It is the forecaster's honest way of saying the season could go any which way here. Across much of the country this summer, the precipitation outlook falls into that equal chances bucket. The pattern simply does not give a strong steer on rain for large parts of the interior and the middle latitudes during the warm season. That is not a failure of the science. It is the science reporting accurately that the summer El Niño signal for rain in those places is weak. A forecaster who invented a confident lean where the data showed none would be doing worse than useless. Research into past El Niño summers backs this up in region after region. Study the local records, and in many parts of the country, you find a little consistent difference in summer temperature or rainfall that you can pin on El Niño at all. The hot summers and the cool ones, the wet and the dry, sort themselves out for other reasons. The ordinary jostling of ridges and troughs and passing systems, with the distant Pacific pattern too faint in summer to leave a reliable mark. Some summers run hot and some run cool, and El Niño is often not the reason. This is the natural consequence of everything laid out earlier about why summer mutes the signal. The jet stream that carries El Niño's influence deep into the country is weak and pulled north in summer, so its power to rearrange the weather from coast to coast drops away. What remains are the tropical effects over the oceans and along the southern edge of the country, plus the broad, gentle heat lean. The vast middle of the continent, far from the tropics and under a slack summer jet, is left largely to its own devices. It matters to say this clearly, because the loud version of the story gets it wrong. A headline that declares El Niño will seize control of the whole nation's summer overpromises, and the overpromise does a quiet harm. It teaches people to blame every hot week and every dry spell on the pattern, when most of those swings would have happened anyway. The truer picture is humbler. In summer, El Niño is one modest influence among many, decisive in a few places and nearly invisible across much of the rest. None of this cancels the real effects already covered. The quiet Atlantic is real and dependable. The busier Pacific is real. The broad heat lean and the wetter southeast are real tendencies. Those stand. What the equal chances label adds is a fence around them, marking off the large territory where El Niño's summer voice falls silent and ordinary weather takes over completely. Both the real effects and the wide silence belong in an honest account. So the fair summary is a split one. In a handful of places and over the oceans, El Niño meaningfully shapes the season. Across much of the country's interior it barely registers, and forecasters say so plainly by calling the odds even. Anyone hoping this report would hand them a single sweeping change to point at will find instead a scatter of modest, uneven leans and a great deal of ordinary summer in between. That is the truth of it, and the truth is calmer than the headline. Yet there is one place where the summer's weather this year is already tense before El Niño says a word, and where even a modest lean toward rain, or away from it, could matter a great deal. That place is the ground left parched by a hard, dry spring. Some parts of the country came into this summer already dry, and for them the question of rain is not academic. Across stretches of the southeast, and the Carolinas in particular, the spring ran harsh and short of water. Month after month the rain gauges came up light. By the time summer arrived, severe drought gripped parts of those states, with rivers and groundwater running low, and the land thirsty for a soaking it had not gotten. Drought is a slow disaster, and that is part of what makes it easy to overlook. It does not arrive in an afternoon like a storm. It builds over weeks and months of rain that never comes, until the deficit is deep and the soil is hard and the reservoirs are drawn down. By the start of summer, some areas had fallen far enough behind that it would take many inches of rain, spread over months, to climb all the way back to normal. That is a large debt for a summer to repay. This is exactly where El Niño's soft southern lean toward wetter weather could help, at least at the margins. The pattern's tendency to favour more rain across the deep south and the southeast is, in a dry year, a hopeful thing. More frequent downpours could chip away at the deficit, refill the topsoil, and ease the worst of the drought's grip. For land that entered summer parched, a wetter-leaning pattern is welcome news, even a modest one. But the help is uncertain, and the reason cuts back to the hurricane story. A large share of the summer rain that soaks the southeast, especially near the coast, comes from tropical systems, the storms and their remnants that sweep moisture inland. In a normal year, a few of those can deliver much of a region's summer water in a handful of drenching days. El Niño, by suppressing Atlantic storms, may also cut off some of that tropical rainfall. The same pattern that leans the region wetter in general could, by quieting the tropics, leave out one of its biggest sources of summer rain. So the drought sits caught between two of El Niño's effects, pulling against each other. On one hand, the broad southern lean toward more rain works in the drought's favour. On the other, the quieting of tropical storms removes a major channel that would normally carry heavy rain to the coast. Which force wins out will vary place to place and month to month, and forecasters have been careful to flag the uncertainty rather than promise relief. The parched ground may get its rain, or it may keep waiting. There is a geography to this uncertainty worth spelling out. Near the coast, where tropical moisture reaches most easily, and afternoon storms come often, the odds of meaningful summer rain are better, good enough that some coastal areas could see the kind of totals that ease a drought. Push inland, away from the coast and the tropical moisture, and the odds thin. The interior stretches of the drought may find summer rain harder to come by, left to depend on ordinary thunderstorms that come and go without erasing the deficit. Drought carries hazards beyond the obvious thirst, and a dry summer keeps them alive. Parched land and low humidity raise the risk of wildfire, and even the southeast, not known for the fires of the west, can burn when the ground stays dry and the wind picks up. Officials in the dry states have kept a wary eye on fire weather, urging caution with anything that could spark on the days when dry ground, low humidity, and gusty wind line up. A drought is not only an absence of rain, it is a stack of risks waiting on the weather. So for the parched corners of the country, El Niño arrives as a mixed and uncertain guest, promising more rain with one hand while threatening to withhold the tropical downpours with the other. The drought's fate rests on which of those wins through the summer, and on the small mercies of local thunderstorms. That unsettled present leads naturally to the larger question hanging over the whole event. This El Niño is not finished growing, and where it goes from here shapes everything that follows. The El Niño of this summer is still on its way up. It arrived in early summer already past the threshold, and every sign points to it strengthening from here, through the fall and into the winter. That upward path is the most important thing to understand about the months ahead, because an El Niño growing toward its peak is a very different force from one that has arrived and stalled. The forecaster's outlook is unusually confident on this point. They put the odds of El Niño continuing through the coming seasons at nearly certain, effectively a lock through the fall, and holding at better than 9 in 10 right through the heart of winter. There is little suspense about whether the pattern will persist. The real questions are about how strong it becomes and when it crests, and on those the forecasts speak in careful probabilities rather than flat predictions. The expected shape of the event is a build toward a late-year peak. El Niño tends to reach its greatest strength in the late fall and early winter, and this one is forecast to follow that familiar arc. The models bring it to a moderate strength through the summer, then push it stronger into the fall, with the crest most likely arriving around the turn of the year. So the pattern shaping this summer is not yet showing its full hand. Its most forceful months lie ahead, aimed squarely at the winter. That timing lines up with everything covered earlier about the seasons. The pattern peaks in winter, and winter is exactly when El Niño's grip on American weather is strongest. So the event is set to reach its full strength at the very moment the country is most sensitive to it. This summer, in a sense, is the opening act, the pattern flexing over the tropics while the continent feels only gentle leans. The main performance over the land waits for the cold months when the jet stream is strong and easy to move. How strong is strong enough to matter? Forecasters graded the likely peak in tiers, and this event is expected to reach at least a solid moderate level, with a real chance of climbing into the strong category and beyond. By one reckoning, the odds of it becoming a very strong event by the depth of winter ran close to 2 in 3. A very strong El Niño is a rarer beast, and one of that size would tilt the winter odds harder than a moderate event ever could, deepening whatever leans the season brings. There is a reason forecasters watch the upper ocean so closely as this builds. Beneath the surface of the western and central Pacific sits a deep store of warm water, the reserve mentioned earlier, and this year that reserve is large. That hidden heat is the fuel for further strengthening. As it drifts east and rises, it feeds the surface warming and pushes the event stronger. A big subsurface reserve is one of the clearest reasons the models expect this El Niño to keep climbing rather than fade early. The tank, so to speak, is full. Still, the outlook holds room for surprise, and the forecasters keep saying so. Every El Niño is different, and a few have defied the models, arriving weaker or stronger than expected, cresting earlier or later. The confidence that the pattern will persist is high. The confidence about its exact peak strength is lower, and honestly so. A range of outcomes remains on the table, from a strong but ordinary event to one of the more powerful in the record, and the coming months will narrow that range as the ocean shows its hand. What is not in doubt is the direction. This El Niño is strengthening. It is expected to keep strengthening into winter, and it is aimed at the season when it can do the most. For the summer, that means the leans described so far are likely to hold or firm up gently as the weeks pass. For the year, it means the biggest chapters of this story are still unwritten, waiting on the winter, and it raises the question that has drawn the loudest headlines of all. Just how big could this one get, and might it break records? The word record has hovered around this event since spring, and it deserves a careful answer rather than a loud one. By one honest measure, this El Niño could indeed rank among the strongest ever recorded. By another, equally honest measure, it looks more ordinary. Both readings come from real science, and the gap between them is the whole story of the record question. Start with the case for a record. The raw heat in the tropical Pacific this year is genuinely striking. The store of warm water beneath the surface is immense, large enough that some forecasters have compared it to the reserve that fed one of the mightiest El Niños ever measured, the giant event of the late 1990s. Several of the models that track the ocean's temperature directly have projected this year's warmth climbing to rival that historic peak. Measured purely by how hot the water gets, a record is on the table, now the counterweight, which comes from the newer yardstick introduced earlier. That relative measure, the one that compares the Niño region against the rest of the warming tropics, tells a cooler story. Judged against its warmed-up neighbours rather than against the cooler oceans of decades past, this year's event looks strong but far from historic, closer to a solid moderate peak than a record one. And crucially, that relative measure tracks how the atmosphere actually behaves better than the raw temperature does. It is the better guide to real-world effects. That split resolves into a phrase forecasters have used to keep it straight. The ocean part of this El Niño may set records, while the climate part, the way it actually pushes the weather around, is likely to be more modest. The water may run historically hot, yet the atmosphere may respond as it would to a merely strong event, because so much of that record heat is the warming world beneath the pattern, rather than the pattern itself. A record thermometer reading does not have to mean record weather effects. This is why you can find two confident, contradictory-sounding headlines about the same event. One warns of a possible record-breaking El Niño, and it is reading the raw ocean heat. Another calls it a strong to moderate event with ordinary effects, and it is reading the relative measure and the likely atmospheric response. Neither is wrong. They are answering different questions. The honest reader holds both, understanding that the ocean's record and the weather's response have quietly come apart in a warming world. For what people will actually feel, the relative, more modest reading is the better guide, and forecasters lean on it for that reason. The effects laid out in this report, the quiet Atlantic, the heat lean, the wetter southeast, all flow from how the atmosphere responds, and the atmosphere is likely to respond in line with a strong to moderate event rather than a monster. So even if the ocean makes history by the old thermometer, the summer and the winter it shapes are more likely to feel forceful than unprecedented. There is a coda to the strength question that looks past this event entirely. The same analysis that trims the event's effective strength also suggests what may come after. When this El Niño finishes its run, likely fading through next spring, the pattern may well swing back toward its cold phase, toward La Niña, later in the following year. The oscillation keeps swinging. This warm phase, however big it grows, is one beat in a longer rhythm, and the cold beat may already be waiting on the far side of it. So the record question ends not with a yes or a no, but with a distinction worth carrying forward. Yes, the ocean may run historically hot. No, that does not guarantee historic weather, because the modern warm baseline inflates the raw number, while the relative measure holds the true strength closer to strong to moderate. It is a subtle answer, and a calm one, and it is the accurate one. That same event, whatever its final size, does not confine its reach to the United States, and the wider world is already feeling it in its own ways. Step back from the United States, and El Niño reveals itself as a truly global pattern, reshaping weather on nearly every continent at once. The warm patch of Pacific water that quiets the Atlantic and leans the American summer warm is, at the same moment, shifting rains and droughts across Asia, Africa, South America, and the Pacific Islands. It is one of the few weather patterns whose influence spans the whole planet, and this year is no exception. The reach begins right at the source. Around Indonesia and the Western Pacific, where the rising rainy air normally sits, El Niño tends to bring drought. The rising branch of tropical air has slid east, away from those islands, taking its rain with it. So the Western Pacific, usually wet, leans dry during an El Niño, and this year the pattern points that way again. For the farmers and forests of that region, an El Niño year is often a year of water shortage and heightened fire risk. Across the Indian Ocean, the effect reaches the great monsoon that waters South Asia. El Niño years often bring a weaker monsoon to India and its neighbours, with below-average seasonal rains across much of the region. The monsoon is the lifeblood of agriculture for a huge share of the world's people, so even a modest shortfall carries real weight: thinner harvests, strained water supplies, harder growing seasons. Forecasters in the region this year have flagged the risk of a lighter monsoon, watching the Pacific with the same care Americans watch it for hurricanes. Africa feels the pattern too, in ways that differ sharply by region. Parts of the northern Greater Horn of Africa lean toward drier conditions during an El Niño, and forecasters there have warned of below-normal rains across a swath of that already water-stressed region during its critical wet season. In a place where rainfall means the difference between harvest and hunger, that lean matters enormously. The same distant Pacific warmth that promises Americans a quieter hurricane season can promise families in the Horn a harder year at the well and in the field. South America sits close to the action and feels it strongly. The warm coastal waters that gave El Niño its name return, disrupting the fisheries off Peru and Ecuador as the cool, nutrient-rich upwelling shuts down and the fish move away or thin out. Rainfall patterns shift across the continent, bringing heavier rain and flooding to some regions and drought to others. For the fishing communities that first noticed this pattern centuries ago, its return is felt directly, in the catch that comes up light and the sea that runs warm. These global effects are not side notes to the American story. They are the same story, seen from other shores. A single warm patch of equatorial ocean is redistributing the world's rainfall all at once, giving to some regions and taking from others, and the American summer is just one chapter in a book being written on every continent. Understanding that scale is part of understanding why forecasters treat this pattern with such seriousness. It moves the weather of billions of people. The human stakes sharpen the point. The regions most affected by El Niño's drying include some already living close to the edge of drought and hunger. When the monsoon weakens or the Horn's rains fall short, the consequences reach far beyond an inconvenient forecast, into food supplies, water security, and the fragile margins of agriculture in poorer places. This is why global agencies issue their own El Niño warnings, not as curiosities but as calls to prepare, so that governments and aid groups can ready themselves for the shortfalls the pattern makes more likely. There is a hard symmetry in all of this worth sitting with. El Niño does not create or destroy the world's weather so much as move it around, and the moving has winners and losers. A quieter Atlantic spares American coasts, while a weaker monsoon strains Asian farms. The same event brings relief to one place and hardship to another, indifferent to the borders it crosses. The warm patch of ocean plays no favourites. It simply tips the great scales, and the whole world adjusts to where they land. To sense what those adjustments can look like at full strength, it helps to remember the last time the pattern grew truly large. The best way to picture where this event might lead is to look back at the last time El Niño grew truly strong. About a decade ago, the pattern built into one of the most powerful events on record, a giant that peaked across the winter and left its mark on the entire planet. Studying that year, and the handful of other strong events before it, is how forecasters set their expectations for this one, and how the rest of us can imagine what a big El Niño really does. That last great event pushed global temperatures to record heights. The years around its peak became, at the time, the warmest ever measured, and they remain among the hottest on record even now. The warm ocean poured its heat into the air, and the planet's average temperature jumped in response, exactly the kind of global spike forecasters expect from this year's event as well. It was a vivid demonstration that a strong El Niño can shove the whole world's thermostat upward for a year or more. Its regional effects played out much as the patterns predict. The Atlantic hurricane season during that strong El Niño ran quiet, its storms suppressed by the hostile winds, while the Pacific stayed busy. Rains shifted across the globe in the familiar way, drought in the western Pacific and parts of Asia and Africa, flooding rains in parts of South America and the southern United States come winter. The event followed the script on a grand scale, and in doing so confirmed that the script is real. Forecasters lean on years like that one when they build this year's outlook. They gather the past events that most resemble the present setup, the analog years mentioned earlier in the hurricane story, and they study how those seasons unfolded. When several strong past El Niños all delivered quiet Atlantic seasons, that history strengthens the confidence in a quiet season now. The past is the forecaster's laboratory, the only place to see how the pattern actually behaves at full strength rather than in theory. But the past teaches humility as much as confidence, because no two events match. Every El Niño carries its own timing, its own strength, its own quirks of geography, and those differences ripple into different effects. One strong event might dump record rain on California, while another leaves it dry. One might bring a mild winter to the north, while another turns harsh. The family resemblance among El Niños is strong, but each is its own individual, and forecasters are quick to warn against expecting this one to copy any predecessor exactly. This year adds a fresh wrinkle that the older events did not have, and it circles back to the two yardsticks. When that last giant event struck, the world was cooler than it is now, so its raw ocean temperature and its true pattern strength were closer together. This year, with the global baseline higher, the raw temperature may match or exceed that giant while the effective strength runs lower. So this event might read as a record setter by the thermometer, yet behave more like a merely strong one. Comparing it to the past means adjusting for a world that has warmed in between. The practical use of all this history is calibration, not prophecy. Looking back tells forecasters roughly what a strong El Niño can do, which effects are dependable and which are fickle, how large the global temperature spike might run, how quiet the Atlantic might get. It sets the range of the reasonable. It does not pin down the single outcome, because the pattern reserves the right to surprise as it has before. The past is a guide to the neighbourhood, not a map of the exact street. So the last great El Niño offers both a warning and a reassurance. It shows what the pattern can do at full force: the record heat, the quiet Atlantic, the redistributed rains, and it grounds this year's outlook in real experience rather than guesswork. At the same time, it insists that this event will write its own version of the story, close to the old one in outline but different in the details. That built-in uncertainty is not a flaw in the forecasting. It is the honest heart of it, and it is worth understanding on its own terms. For all the confidence in this forecast, it is worth being clear about what forecasters cannot know, because the honesty of the whole enterprise rests on that clarity. Seasonal prediction is a science of odds, not certainties. It tells you which way the dice are loaded, not how they will land. Anyone who reads an El Niño outlook as a schedule of coming weather has misread it, and the misreading breeds the kind of false expectation that erodes trust when a season does not behave. The core limit is built into the pattern itself. El Niño shifts probabilities, it does not dictate events. A season under its influence is more likely to unfold a certain way, but any single month, week, or day can still break from the lean. A summer forecast to run warm can still deliver a cool stretch. A quiet hurricane season can still spawn a monster. The pattern tilts the field. It does not decide the game, and the ordinary chaos of weather plays on top of it, free to defy the odds at any moment. Some of the sharpest limits attached to the details people most want. Where a hurricane will strike, whether a particular city gets rain in August, how hot a specific week in July will run, these are beyond the reach of a seasonal outlook entirely. They depend on weather patterns that form only days ahead, far too late for a forecast made months in advance to capture. El Niño can say the basin will likely be quiet. It cannot say your town is safe. That gap between the seasonal and the specific is permanent, not a temporary shortfall in the science. Even the pattern's own future carries real uncertainty, as the strength question showed. Forecasters are confident this El Niño will persist and strengthen, but its exact peak, its precise size, its timing to the week remain fuzzy. Every El Niño is a little different, and a few have thrown off the models, arriving weaker or stronger, or later than expected. The confidence is high on the broad path and lower on the fine print, and good forecasters mark that difference plainly rather than papering over it. There is a particular humility around summer, which this report has returned to more than once. The warm season signal is genuinely weak across much of the country, and forecasters know it. That is why so many summer outlooks land on equal chances, and why research finds little El Niño fingerprint on summer weather in many regions. A forecaster who claimed to know your summer in detail because El Niño arrived would be overstepping the science badly. The truthful summer forecast is often a shrug dressed in probabilities, and that shrug is the science working correctly. None of this is a reason to dismiss the forecast. A loaded die is still worth knowing about, even if you cannot predict a single roll. Knowing the Atlantic season leans quiet, the summer leans warm in the north, the southeast leans wet, the drought's fate hangs in the balance, all of this is genuinely useful for planning and preparing, precisely because it shifts the odds in knowable ways. The value of a probability forecast is real. It is just a different kind of value than a certainty would offer, and it must be used as what it is. The right posture, then, is to take the leans seriously while holding them loosely. Plan for the tendencies, the quieter Atlantic, the warmer north, the wetter southeast, but stay ready for the season to surprise because sometimes it will. Trust the broad shape of the outlook and distrust any claim to fine detail months out. That balance between respecting the forecast and remembering its limits is exactly how the forecasters themselves hold their own work, and it serves the public just as well. So the limits are not weaknesses to hide, but features to understand. The forecast is a lean, not a lock. It is strong on the season and silent on the day, confident on the broad path and humble on the details, and weakest of all in the summer it is trying to describe. Held that way, honestly and lightly, it becomes a tool rather than a false promise. And a tool is meant to be used, which raises the plain practical question of what a person should actually watch as this event moves forward. With the limits understood, the useful question becomes simple. What should a person actually watch as this El Niño moves through the summer and toward its peak? The answer is a short list of markers, most of them updated on a regular schedule by the agencies that track the pattern, and following them is easy once you know where to look and what the words mean. Start with the monthly updates. On a set day each month, the forecasters release a fresh diagnosis of the pattern, the latest ocean temperatures, the newest read on strength, and updated odds for the seasons ahead. Those updates are the heartbeat of the forecast, the place where any change in the outlook shows up first. Following them, even loosely, keeps a person current on whether the event is strengthening as expected, stalling, or surprising the models. They are the single best habit for anyone who wants to track this. Watch for the seasonal outlook updates that come with the calendar. Ahead of the peak of hurricane season in the late summer, the forecasters revise their Atlantic outlook, sharpening the early call as the season's shape comes into focus. That mid-season update is worth noting because it will confirm or adjust the quiet season expectation just as the most active weeks approach. If El Niño has strengthened on schedule, expect that update to hold or deepen the below normal call. Keep an eye on the strength category as the pattern climbs. The move from moderate towards strong, and the question of whether it reaches very strong by winter, is the storyline that will shape the cold season most. As the subsurface heat rises and the surface warms further, the updates will track that climb. A pattern reaching the strong or very strong tier tilts the winter odds harder, so watching the strength is really watching how forceful the winter chapter is likely to be. For the hurricane-exposed coasts, the watching turns local and short range as summer deepens. The seasonal outlook has done its job by setting expectations, and from here the forecasts that matter are the ones tracking specific storms in the days before they arrive. Anyone on the Atlantic or Gulf Coast should keep the ordinary storm season habits, watching the tropics through the peak weeks, and heeding any warning that names a real storm, quiet season or not. The Pacific Coast and Hawaii should watch their own tropics, with a touch more attention than usual this year. For the drought-stricken areas, the thing to watch is the summer rain, week by week. Whether the southeast wetter lean delivers, whether the coastal downpours come, whether the tropical moisture reaches inland, these will decide the drought's fate over the season. Local rainfall reports and drought monitors, updated regularly, tell that story as it unfolds. A run of good soaking rains would ease the worst, while a dry summer would deepen it, and only the weeks ahead will show which way it breaks. For most everyone else, across the great middle of the country where the summer signal is faint, the honest advice is to watch the ordinary local forecast and not much else. El Niño is unlikely to change your summer in ways you would notice, so the daily and weekly forecast remain your best guide, just as in any year. There is no need to read El Niño into every hot afternoon. The pattern is real, but for much of the country it is a background hum, not a headline. The deeper thing to watch for is the turn toward winter, because that is when the pattern will finally speak at full volume over the land. This summer is the quiet opening. As fall arrives and the jet stream strengthens, the outlooks will shift toward the winter story, and that is when El Niño's clearest American effects will come into view. Following the pattern through the summer is really preparation for reading the winter, when the leans grow firm and the stakes over the continent rise. That longer arc points toward how a person lives with the pattern here and now. Living with an El Niño, summer does not ask much, and what it asks is mostly ordinary good sense. The pattern is a background condition, not an emergency, and the wise response is to adjust a few habits gently rather than brace for upheaval. For most of the country, the practical guidance comes down to two things: respecting the heat and keeping the normal storm season readiness, both of which are worth doing in any summer and a little more worth doing in this one. Take the heat first, because it is the most widely relevant. With the summer leaning warm across much of the country and the world running hot beneath it, heat is the hazard most people will actually meet this season. The steps that blunt it are simple and familiar. Drink water before thirst sets in. Find cool air or shade during the fiercest hours of the afternoon. Ease off hard outdoor work when the heat peaks, and know the early signs of heat illness, the dizziness and cramps and heavy sweating that warn a body is overheating. The heart of heat safety is looking out for the vulnerable, because heat harms unevenly. The old, the very young, the sick, and those without cool air at home bear the brunt of it. And many heat deaths are quiet, happening indoors to people alone. A phone call to an elderly neighbour on a brutal afternoon, a check on a relative who lacks air conditioning, a ride to a cooling centre for someone who needs it. These small acts save lives during hot spells. In a summer leaning warm, that neighbourly habit is the single most valuable thing on this list. For the hurricane coasts, the guidance is the standard season readiness, held to despite the quiet outlook. Know your evacuation zone and your route out before a storm is ever named. Keep a basic kit stocked: water and non-perishable food, medicines, flashlights and batteries, enough to carry a household through several days without power. Keep away to receive warnings when the power fails. None of this changes because the season leans quiet. The one storm that matters does not consult the outlook, and readiness is cheap insurance against it. For the drought-touched regions, living with the season means a watchful eye on water and fire. Where the ground stays dry, ordinary caution with anything that could spark a fire matters more than usual, especially on the days when low humidity and wind join the dryness. Following local water guidance, and any burn restrictions officials put in place, is part of living responsibly through a drought. The land under stress needs a little extra care from the people on it until the rains return. The steadiest habit of all is simply staying informed through trustworthy sources. The forecasters and agencies that track this pattern put out clear, regular, freely available information, and leaning on that rather than on rumour or hype is the calmest way to live through any weather season. When a real warning comes, heed it. When the noise says the sky is falling, check it against the official word first. A little media caution goes a long way toward keeping a season in proportion. Above all, the right way to live with this El Niño is without fear. It is a natural pattern, one that has come and gone through all of human history and long before it, and the world has always adjusted. It leans the odds, it shifts the risks, it rewards a little preparation, and then it passes, giving way to neutral and eventually to its cold twin. Treating it as a reason for steady, sensible readiness rather than alarm is not just the calmer choice. It is the accurate one, matched to what the pattern actually is. So the whole practical weight of this event for the ordinary person rests on a handful of quiet habits. Respect the heat and mind the vulnerable. Keep the storm season readiness whatever the outlook says. Watch the water and the fire risk in the dry places. Stay informed and stay calm. That is what living with an El Niño summer really means, and it leaves only the last question of where exactly this whole event stands as the season turns. So where does it all stand? A warm patch of the tropical Pacific tipped into El Niño in the early part of this summer, and the forecasters made it official when the water crossed the line and the atmosphere shifted to match. The pattern is here, it is real, and it is measured. That much is settled beyond doubt, and it is the firm ground under everything else in this report. What is known reaches a good way past that. The event is strengthening and is expected to keep strengthening into the winter, when it will crest and speak most clearly over the American land. Its surest mark on this summer is a quieter Atlantic hurricane season, driven by hostile winds aloft, paired with a busier Pacific. The summer leans warm across much of the country, warmer and more certainly so across the globe, with the southeast leaning wetter and the north leaning hottest. Those are the dependable threads, grounded in physics and in the record of past events. What is uncertain is just as important to name plainly. The exact peak strength of the event is not yet fixed, though it is likely to land somewhere between solid, moderate and very strong. Whether it sets records depends on which yardstick you use, the raw ocean heat pointing one way, and the truer relative measure pointing to something more ordinary. The fate of the spring drought hangs between the region's wetterline and the loss of tropical rainfall, and across much of the country's interior, the summer signal is simply too faint to call, which the forecasters admit by leaving the odds even. Hold the two readings of strength together one last time, because they capture the whole spirit of this event. By the old thermometer, this could be among the hottest tropical Pacifics ever measured. By the measure that better tracks how the atmosphere behaves, it is strong but familiar, one more solid event in a long line of them. Both are true. The honest expectation is a forceful but not unprecedented pattern, felt firmly over the oceans, gently over the land, and most of all in the winter still to come. The next thing to watch is that turn toward winter. This summer has been the quiet opening act, the pattern flexing over the tropics while the continent felt only soft leans. As fall arrives and the jet stream strengthens, El Niño will find its full voice over North America, and the outlooks will shift to the winter story, where its clearest American effects will finally show. The monthly updates will track the climb toward the peak, and the late summer hurricane outlook will confirm or adjust the quiet season call as the most active weeks approach. There is a longer horizon worth keeping in view as well. This warm phase, however large it grows, is one beat in a rhythm that never stops. It will likely crest around the turn of the year, fade through the following spring, and hand the Pacific back toward neutral, and perhaps on toward its cold twin later in the year after. The oscillation swings on, as it always has. This El Niño is a chapter, not the whole book, and the next chapter is already forming behind it. The title of this report promised that El Niño was about to take control of America's summer, and the honest verdict is a measured one. It has taken a firm hold over the oceans and a gentle hold over the land, real but softer than the grip it will take in winter, and fainter still across the wide interior where ordinary weather rules. It shapes the season without seizing it. That is the truth of an El Niño summer, calmer than the loudest headlines and steadier than the fear they can stir. For now, the pattern is set, the leans are drawn, and the country moves into its summer under a warm Pacific's quiet influence. Watch the heat, respect the storm season whatever the outlook says, and keep an eye on the updates as the pattern builds toward its winter peak. That is where the next report will pick up the thread when El Niño finds its full voice over the land. Until then, stay calm, stay ready, and stay curious about the vast, quiet machinery of the sky.